How's it going, everybody? Today we are doing Lab 9, which is biomechanics. Definition. Biomechanics is a study of biological phenomena, which is process, function, and structure, using the methods of mechanics, which is the study of motion. It is also the way in which humans and other species move their limbs and bodies in space through cellular processes such as transport of nutrients across cell membranes. Laws of physics hold true for everything, including living organisms. So we're going to talk about humans, of course. Biomechanics there on your left side, principles of balance, equilibrium, motion, and application of forces. On your right, engineering mechanics, diffusion, acceleration, velocity, and force. We'll start with velocity. Velocity is the rate of change of displacement. So displacement and distance are different. Velocity is a vector quantity, which means it has a direction. So something has to go from point A to point B in order to have a velocity, meaning that if you're on a 400-meter track and you run a 400-meter race and you start and finish at the same point, your displacement would be 0 because you went from point A to point A. However, your distance would be 400 meters. So it's important to know the difference between displacement and distance, because velocity is displacement and the change in time, not distance. So how long it takes the subject to go from point A to point B. Equation for velocity is change in displacement over time. Units are meters per second. Next slide is momentum. Momentum is the product of mass, which is the weight in kilograms, times velocity. So equation is mv. Momentum equals mass times velocity. Units are kilogram meters per second. Next slide is kinetic energy. Kinetic energy is defined as the energy that an object possesses as a result of its ability to do work. So a measure of an object's ability to do work, force times distance. Equation, kinetic energy equals 1/2 mass times velocity squared. That velocity should be in parentheses because you should square your velocity before you do the rest of the calculation. Units, 3 different types of units you could use for this: kilogram meters squared per second squared, joules, or newton meters. And we'll use joules for our purposes. So that is kinetic energy. Moving on, acceleration for the next slide. Acceleration is the change in velocity. Equation, acceleration equals the change in velocity over time. Units for acceleration are meters per second squared. And another thing we know about acceleration is that we're all constantly being accelerated at 9.81 meters per second squared downward towards the Earth. That happens without any change ever. Okay, so we always need to take acceleration of gravity into account. Reminders: 1 inch equals 2.54 centimeters. 1 pound equals 2.2 kgs. And 1 mile equals 1.6 kilometers. So we need those when we do our conversions from our English into our metric units, which we need to do these calculations. All right, I will also follow up with the data sheets and explain those.